Okay, so this is the recording of our fan car going slowing down in the negative direction. Okay. And
Okay,
then
from this that we figured out our position time graph, and that's our top graph. Um, but since it's not linear, we have to linearize it, and we found that it's
okay, like I'm sorry, I reached size of the graph to show you that it's not linear because when you stretch it out like this, it looks kind of linear. But as you can tell, it's curved, and near the bottom, the slope of it approaches 0. And basically, what that means is that the fan car is slowing down. And yeah, so you wanna
yeah. So the proportion is y to 1/x. So we did the position over versus 1/time, and that got us the linear equation with a constant slope, which was about 11.8 or 11.9 inches. Uh,
and then our equation is
so yeah, so our equation that we got for our position graph was position equals 11.89 inches over 1/seconds times 1/time minus 38.49 inches. So the 38 point basically 5 inches is our starting or initial position, because that's at time equals 0 what your position is, and then the 11.89 inches over 1 second is our slope, and that's how it's changing each second. Um,
so it seems really illogical when you look at the units, but it works out because the seconds cancel out with time, and you're just left with inches per second, which is a velocity. Okay, and then for the velocity graph, basically we graphed time and then the position divided by time, which is what velocity is, and you get like a line like this, but with a slope, because oh, and first of all, because your velocity graph is like a tilted line like this, that means that the motion of the fan cart is it's speeding up, but also it's what's it called? Okay, I'm sorry. It's not speeding up because it just has a positive acceleration because the slope is positive, but it's actually slowing down because the velocities are like really negative already, and they're getting closer to 0. And then what that basically means is yeah that the fan cart is slowing down because it's a negative velocity, and yeah it's approaching 0. And then yeah the slope of this velocity graph basically yeah like the same thing I just said it. Okay, so looking at this graph, we get the equation that's, where is it? Okay, velocity is equal to 11, about 12 inches per second over seconds times time minus 38 inches per second. And basically your minus 38 inches per second, that's your intercept, and like on the vertical axis. And that means that when time was 0, the cart was moving at 38 inches per second. And then for the slope of this equation, when we have 12 inches per second over seconds times time, that means for every second, the velocity was increasing 12 inches per second. And then lastly, if we look at the displacement of velocity graph, let's look at like, I don't know, about here. Oh, my computer's going slow. Okay, so this is the integral, which is the area underneath the curve. We get negative 31.38 seconds times inches over second, which is basically inches. And what that means is that from the initial position, that's how many inches the cart has moved. So from the initial position from the initial position of negative 40 inches, the cart basically moved almost all of that with negative 31 inches, but it also moved that in the negative direction.